Okay, thanks everyone for coming along. Hello, my name is Don Syme. I'm a principal researcher at Microsoft Research in the United Kingdom, and I am a sort of long-distance virtual member of the Visual Studio Pro team, the Visual Studio Pro Experience team. That's the team who bring you C#, Visual Basic, F#, and a lot of the core functionality that you have in Visual Studio. So it's my pleasure today to be here at Build and to be able to present to you the latest work we've been doing with F# 3.0. Very excited that the release has gone out this week. You can use it today if you download the preview release of Visual Studio 2011. That's not the Windows 8 developer release you have on the devices you've been given this week, which is focused on making the Metro apps, but this is the Visual Studio 11 release that's been available to MSDN subscribers since Wednesday, and I think is available for general download from, I think, either yesterday or today. So, so today I'm going to be talking about F# 3.0, what's new in F# 3.0. And before I begin, I'd like to just recap a little bit about our philosophy at Microsoft about the role of the F# language and what areas and kinds of programming we expect F# to be used for. And this is very important for us in the F# core team. It's very important that we have a focus that we don't try and chase every single domain of programming, that we don't try and sort of become another C# or another Visual Basic. Don't try and displace those languages. We need to focus as a team on areas of programming where F# have really strong affinity and where F# gives a substantial productivity improvement when used correctly and when used in conjunction with other tools that are available in Visual Studio. So to understand my view of the world in this regard, and I think this is commonly accepted view of most software construction, there are essentially three layers in any software project. Some projects only have one or two of these layers. In some projects, some layers are far more emphasized than others. But at the core of anything where there's a substantial amount of programming, there's going to be what we'd think of as the code and the logic, the transformations, the analyses, the algorithms, the code. At that layer, you're going to be dealing with complex problems, perhaps, such as parallel programming and multi-core programming. But this is essentially the code-focused, the problem of using the local machine to its maximum effect, the problem of implementing data transformations or data analyses and algorithms. And this has always been a traditional sweet spot for the functional programming paradigm, which is at the core of the first and foremost in the F# programming language. To the left, this perhaps could have been a layered diagram, but I've placed it across here. To the left, we have the problem of data access, data, services, and information access. That, to me, in this talk, this is the part that this talk is really all about, how F# is entering into this territory and the features that we're adding to make F#, the reach of F# reach down to your data access layers and in your applications. When I visit enterprises, I've been quite surprised over the last years as I've done sort of applied research of working with enterprises, working with financial institutions and other institutions picking up F#. Just the sheer proportion of code in enterprises, which is related to data access, in a sense constructing the presentation of data for the rest of the enterprise. At the core of many enterprises is a team whose responsibility is sort of the core data team. The responsibility is to clean and present data for the rest of the company, and often presenting it ultimately in the form of a set of APIs or a set of services which can be consumed from various client applications. And now on the right, we've got the topic which is really the really major focus of the Build conference, about presentation, publication, and experience of the artifacts that are ultimately produced by the left-hand side. And I interpret this in a very broad sense. We may have ASP.NET applications where everything is done on the server side. We may have JavaScript applications where all three of these activities are actually done in JavaScript. So it's not necessarily a client-server divide, it's just a divide between data, code, and presentation. When you look at what we did in F# 2.0, our focus was very much on the center activity, enabling functional programming as a viable option for this portion of your applications. And so when you see people using F# in Visual Studio 2010, you'll very frequently see one F# project combined with some data access done in C# and, or Visual Basic. I've always been told off by the Visual Basic guys, I have to say, or Visual Basic. Okay. And you'll see a lot of presentation code, again, done in C# or Visual Basic normally, or perhaps done in HTML5 and JavaScript. We're seeing that emerge as a combination more with F# programming. The focus of F# 3.0 is all about data services and information access, and about doing something very special in the language, which allows F# to be a unique language for accessing rich information spaces with a fluency of a kind that no other language can achieve. And I hope by the end of today's talk you'll understand what some aspects of what I mean by that. So from the F# perspective, this is where F#'s use lies, in these two domains. And from the F# perspective, that means we are very, very happy to be working with C#, Visual Basic, HTML5, and JavaScript over on the right as the primary mode for presentation, publication, and experience. And of course, over on the right, that's the focus of build. But for the purposes of this talk, we're looking more at the traditional inner part of these applications with data services, algorithms, and code. Okay, so our focus is over here for this talk. So in that light, obviously, there's been a lot of this conference is about the metro development, and people will have questions about what's the role of F# in that kind of development, also what's the role in phone or ASP.NET and Silverlight development and the like. So I just want to say up front that our roadmap for F# 3.0, this is not in the developer preview, but our roadmap is to support the portable profile for the libraries, which F# is built on, .NET libraries. And the portable profile will allow you to use your F# code on the Metro, on the desktop, and Silverlight, and so on. So that means you will continue to use a C# or a Visual Basic front-end project, or perhaps a JavaScript and HTML5 front-end project. And that philosophically, for the F# team, nothing has changed here. This is always the approach we've taken for any of the various client-side experiences. The client side is an amazing, rich environment. Things are developing in the client side. They have been all the way through from WinForms through to ASP.NET, through to Silverlight, and through to Metro, and many other, and WPF and the like. And from the F# perspective, we stand back from that a little bit and focus on this core constituency of data services, transformation algorithms, and code. Just to give an example of this is an example that somebody built within 1 hour of downloading the Visual Studio 11 bits. And what I like about it is this matches exactly the structure that we see frequently, and not only with F# 2.0, but that structure that we want with F# 3.0, where they're using F# 3.0 within an hour of downloading this Visual Studio 11 developer preview. They had their F# data acquisition, query, and analysis layer over on the right. They had their C# front-end ASP.NET application above, and there's ultimately the ASP.NET application there. I'll show a small application like this. We'll use ASP.NET. It's a little bit retro to use ASP.NET as a presentation layer, but my approach to doing user interfaces and in conferences is to leave it up to you, all your wonderful client-side programmers who can do all the fancy graphics, all the fancy WPF and the Metro applications and everything else. And we just do some core data analysis kind of work. So you don't expect anything too visually fancy from an F# talk. Okay, so F# itself, a productive, supported, interoperable, functional programming language that allows you to write simple code to solve complex problems. And I hope you see that this is our core mission statement as a team. And I hope you see that the adjectives we've chosen are essential to understand the previous slides, that interoperability is absolutely critical for the F# language, because we need it to be very seamless to be able to interoperate from C# into F# code and vice versa. So just a reminder about what F# actually gets used for. I think the best summary term is analytical programming. And to give one example of the use of F#, we have a lovely quote from a man called Simon Cousins, who uses F# in the context of a power generation company. This power generation company needs to make difficult decisions about how much power to be producing from their various power stations across the UK. And that will depend a lot on the price of power, because power can be transferred across country boundaries and all sorts of other interesting kind of phenomenon. And they need a calculation engine, and that calculation engine was written in F#. I actually don't know how that is ultimately deployed, whether that's ultimately deployed as a service or whether it pushes the decisions to some controlling center, and then humans actually make the ultimate decisions about power generation, I presume. But the point is the calculation engine was written in F#. It gets deployed into some software context. And his summary of why the technical features of F# were effective in this problem domain, it's very interesting. But his short summary is that it addresses the complexity at the heart of the application, and that the sweet spot is about the algorithmic analysis of large data sets. There are other sweet spots for F# besides that, but that's the one that Simon chose to draw out here. Okay, so let's move on to F# 3.0. So understanding what we're doing in F# 3.0 is pretty straightforward. I think a critical development in programming language design, in compiler design and tooling design. I think it's an essential step given the trends in the industry around data and information. So the world is extremely information rich. We experience that information richness every day that we use the internet. We experience it every day that we use our devices, as these devices are in themselves not necessarily that interesting. What makes connected devices so interesting is that they are connected through to a very rich information context, which is the modern internet, which is the modern web. We experience that information richness in the enterprise. That's been sort of the home of information-rich environments for a long time, the database programming, the service programming that people have been doing in those contexts. So not only is the world information rich, but there is an explosion in the amount of data and an explosion in the degree of organization of that data and the availability and reliability in the availability of information. It would have been inconceivable 5 or 10 years ago to build the kind of phone and the rich devices that we use today, because the information base wasn't available on the web. But our languages and our frameworks are themselves information sparse. And what I mean by that is that when you use when you look through the .NET libraries, you don't see a definition of a football player or a bank account or a definition of a chemical element or some basic scientific data. None of this basic notion of information occurs in these frameworks. It all ultimately has to come from outside. Now, that's fine. We're used to being able to do data connectivity of various kinds, but it's a major problem, and for statically typed languages in particular, because there's always an impedance mismatch as we work across the data interoperability boundary. And we have various ways of trying to address this impedance mismatch. We can, for example, do code generation is one technique. We can also resort to using dynamic language kind of techniques where you have a lot of objects or strings being passed across the boundary. But in those cases, all the advantages of statically typed languages tend to start to dissipate. The more information-rich your environment, then the less of an advantage your statically typed language is. And that is a real problem for those of us who love statically typed languages and enjoy the tooling that's available from them. And we kind of know that it shouldn't be like that, right? That the statically typed experience degrades as the information richness grows, because we often have good schemas and metadata for these information sources. And we feel we should be able to do statically typed programming against very rich information spaces. And so we need to fix this. And part of the point of what we're doing in F# 3.0 is that the fix is to change some of our assumptions about compiler and tooling and language architecture, and change some of our notions of what we think about what is a library. And we can start to think about these information spaces as libraries we could use that are just part of our ambient environment, in the same way that the .NET framework is part of our ambient environment for programming. So F# 3.0 is about fixing this. And something I really want to emphasize in this talk is the data access techniques that I'll be showing are available for those of you working in C# and Visual Basic projects inside Visual Studio 11, simply by adding an F# project to your solution, putting your data access, the small parts, however much of your data access code you want to put in the F# code. It's not very hard F# code, very straightforward, very, very familiar to those of you who have been using C# and LINQ or VB LINQ. And you can do that data access in the F# component and then publish the results trivially, very easily to C# and Visual Basic. Now that probably comes as a bit of a shock to the system, to some of those who do C# and VB, because in the F# world, we're always used to having to kind of shell out now and then to do some work in C# as well. So now it comes the other way around a little bit. Some of you might, if you want to use the things being presented here today, you'll have to use F# and add that F# solution, add that F# project to your solution. But go ahead and try it. It's very seamless to do that, so give that a go. Okay, so let's take a look at an example of what we mean by information-rich programming. And this is a challenge that I like to begin with, just to imagine to yourself that you have a job as a consultant, or a part of writing, say, a phone application or a metro application is to write a class library for the chemical elements and to populate it with data, and you want that to be strongly typed. Okay, so how long is that going to take? Well, you have to design the classes. Maybe you have chemical elements. You also want their various properties. You have to start thinking about all the different properties the elements have. You have to start thinking about things like, well, chemical elements have isotopes, so we better have a notion of an isotope along with the elements. And you have to do a whole lot of data modeling. Maybe you'd go and look up some textbooks or look at Wikipedia to start to design this library. And then you have to populate it with data. So maybe you do a bit of screen scraping, or maybe you find a web service which has some of the data you want, combine a couple of web services maybe, and suck that data in. Okay, so how long is that going to take? Maybe a week, 2 weeks? Depends, yeah? And now I want you to think about repeating that for more or less every entity in say, Wikipedia. So every entity in every field of human knowledge, more or less. And you want that to be live and updating, that information store to be updating as people curate it, as people improve it. Let's say it only grows incrementally over time, just assume that. And you want this data store to be sort of part of your ambient programming environment in a strongly typed way. Okay, so let's take a look at what that looks like in F#. So here we have an F# script. So before we begin, I'll just show just a little bit of the usual F# programming here. Let's just load up one of these scripts here. So this is an F# script. I've just created file, new script, and added the references above. And we're using F# Interactive here, which we go view F# Interactive, or if you're working in the C# or Visual Basic profiles, you go view other windows F# Interactive. And you can add an F# script to your C# or Visual Basic project. You just right-click and add it, and you can do scripting. You can use script against the DLLs which you've built in your project, for example. So what we're going to do now is reference this, what is called a type provider, which is at the heart of what we're doing for F# 3.0 information-rich programming. And this type provider looks like a DLL, except it's not a DLL. Okay? Instead of having a fixed set of types, this is a library which will compute types from some backing data store. Okay? It computes a space of types from a backing data store. So it looks and feels like you're using a library, but that library is effectively computed on demand as you use it in your code. So let's open up these namespaces, do an alias declaration here. So now we have that connection. We're using what's called a web ontology, one of these wonderful structured data stores that do things like screen scrape Wikipedia and aggregate other information sources and place them into a structured, curated kind of form for us to use in our applications. And you can see here that we actually have augmented the .NET programming environment with a whole lot of information. Okay, and this is what we mean by information-rich programming. None of this information is particularly easily accessible unless you go and do some REST API calls and JSON kind of munging and all this other kind of stuff. You can do it that way if you like, but it's not that easily accessible to the C# programmer. You could do all that stuff, but you won't find the types there. It's not easily accessible in a strongly typed form. But to the F# programmer, well, they've got information, right? They've got information as loads and loads of it once they go and use this type provider up above, which is connecting them to this information store. So let's take a look. What was our job? I was getting distracted. I'm forgetting my job here, which is forgetting myself that our job is to do the chemical elements. So it seems like our job is not actually particularly hard because we've actually got the chemical elements here in our information base on which we're doing our programming. So we can now have the chemical elements, and we can show some data over here. But before I do that, I'm just going to remember that I forgot to actually show you what this window on the right over does, on the right-hand side does. So I just want to show you some things here. It's just a window for displaying data. So we create a list of the numbers from 0 to 99, for example, and we display them over on the right. You can also show things in a grid form like this. We might generate for I in 0 to 99, generate I and I times I. So you can generate a table form that's generating tuples containing two elements, and it shows you the corresponding table of data over on the right. You'll also see me use what's called pipelining in F#, which is where we take some data like this list of numbers here, and we pipe it over to the right, like this. And you'll see me using a series of transformations to that data in this kind of form. So if we go I, we'll do I and I plus I this time. So we're going to take this list, we're going to map a function, which is like select if you're using link a lot, and returning for each I, we return I and I plus I, and then we show that data over on the right. Okay, so this is pipelining and transformation, and we might do something like filter out where we only want the ones where I mod 2 equals 0, just to get the even numbers. And you can see the table has been filtered down. Okay, so now we've done that, I can get back to the main show, which is to take this data here from the web ontology And we have our data being streamed from that web data source. And in a sense, our job is kind of done. And not only is it done, but it's actually, there are a lot of interesting properties here about chemical elements. These first chemical elements are all the ones which have not actually been discovered yet, but the ones down below begin to look a little bit more familiar down here. Okay. Right, so that data access was nice and easy. We've got this massive number of types available. I just got to bring my show window back up. There it is. So let's take a look at what else we have here. I always like moving up the scientific stack now and look up a little bit higher and take a look at the amino acids, which we've all got inside us. And there's the list of amino acids coming through. And then the world is information rich beyond that. We might want to start looking, for instance, at baseball players and see what the information store knows about them and see what sort of properties they have here. You can see there's all sorts of interesting things here. And what I'm really interested in is the way how once you have information in your hands, all sorts of ideas start coming into the head about applications you can build. Okay, once you have an information-rich environment, you might think, wow, just think of all the different Metro applications that you might build given this information store, right? Do a baseball application. Well, fantastic. If you get your hands on interesting information about baseball players, and you get your hand on a geolocation feed, and you get your hands on the live feed of who's coming up to bat in a baseball game, then you can start to write an application which, as you're sitting at the sporting event, tells you all this interesting information and brings up interesting pictures of who's coming up to bat. It becomes almost trivial now to start to think about what kinds of applications we can build. And when we look at what properties we know about these baseball players, we have their batting statistics, we have their current team, we have their former teams, and because we're working in a strongly typed environment, we have IntelliSense. We have the programming environment helping us to know what information is available in these information spaces and what kinds of information we might propagate across into our user experiences, either in applications or in the enterprise or whichever kind of information-rich environment you're working in. Okay, so that's data access, and here. So of course, things go beyond data access. You also typically have to start doing some data cleaning. So for example, this is where we start to filter out things which for some reason they don't have an atomic number listed, and we start to sort by an atomic number, and we show them on a grid. Over on the right, it begins to look a bit more like the periodic table. And similarly, you might start to move over into that presentation side of my initial slides. You might start to do some presentation of the data and some analysis. Here's, in this one, we've taken the list of, taken the chemical elements, and we've looked at how many isotopes does each chemical element have. And to be honest, I didn't know there were any elements with as many as 40 isotopes up here, but they do have a lot. And it's interesting here that as soon as you get to the radioactive elements, the number of isotopes drops off, presumably because they aren't as stable. Okay, so great. So we have data, and once you have data, there's many different directions that you can go on from that point. Okay, so what you see there is sort of language-integrated web data. Language-integrated, in a way, if you want to use fancy terms, language-integrated semantic web ontologies in this case. So the world's data is being organized and made available in highly reliable ways at an astonishing rate. And the idea of F# 3.0 is that we need languages that breathe big, organized data, that live and thrive off big, organized data. And what we've done to F# is to add this type provider mechanism. And a type provider is in many ways just a plug-in to the compiler, a plug-in to the type checker that's running in Visual Studio. So as you're plugging simultaneously into Visual Studio, into the F-sharp interactive window for evaluation, and into the F-sharp compiler when you do normal project-based programming. So it's an extension to the compiler. It provides libraries on demand. Another way to put it, a design time component that provides a computed space of types and methods, which gives you IntelliSense for these information spaces. It's an extension. It's completely extensible and open. And when you think about it, this is trying to hit many of the same domains as things like add service reference in Visual Studio, which is great. The generated code can be a bit of a pain. You can get all these extra generated files. Modifying service references and the like can be a little bit painful, but it's good. But one of the key things here is that the model is completely extensible and very neutral with regard to service technologies. You can use type providers with WSDL, you can use them with OData, you can use them with SQL data, you can use them with third-party, like the data sources I've been using here. You may have to write a type provider for the data source, and that how hard that is depends a lot on what foundations you're building on. But it is an extensible model. You can do type providers for SharePoint. You can do type providers for WMI, for example. And in many ways, what we're doing is changing the language so we have the static counterpart to a lot of dynamic programming language techniques. We can not only work with the data, but we can make sure that the language can work with the metadata as well, coming from these data services. So as a second example of this, I'd like to point to another example of big data, this time big data in the cloud. And I think one of the key things, so this is called the Windows Azure Marketplace. It's the data market in Windows Azure. And you can just sign in with your Live ID and you can start subscribing to data sets. And there's lots of interesting data sets that are available. And they're all very nicely set up to be able to work with them in Excel or Power Pivot, for example. But to work with them from code, you need to click, you go through to the data set and you need to click this magic button which says download some C# code to paste into my application. Okay. And to me, that's a little bit clumsy for going and working with these data sets. It's nice, but I find it's not as fluent an experience of the data and the information as you can get with F-sharp 3.0. So let's switch over and take a look at using the Azure Data Market here. You do need an app key associated with your account on Azure Data Market. So this is the type provider here. So with this type provider, we're going to project all the information in that cloud data marketplace into the programming experience. Okay? So now we can go along to Windows Azure. We have the marketplace. We can go to the marketplace, and we can go to the data market. And at the data market, on the tables, they have lying around some data sets. So we'll have a look, okay, what have you got here? And we start to see that all these data sets are now projected and available in the F-sharp environment. Now, you do actually need to subscribe to the data sets before you use them. In theory, the type provider could offer that for you, that as you did IntelliSense and you started using one, it would say, oh, you're not subscribed to this. Would you like to subscribe? Please enter your credentials and so on, and it would take you through the subscription process. That's not done in this particular demonstrator, but it could be done. And we can go through to the data sets, and we see all the interesting business and finance data sets. We see the interesting metadata, so we start to be able to sort of navigate and browse the different data sets to decide which ones we want to use. Some of the data sets you do have to pay for, some of them are free. Okay, so once we have that, we can start to actually use the data. The main point of this demo isn't actually what I build on top. The main point is really just seeing the fluency of how the data is embedded into the ambient environment of types that are available to the F-sharp programmer once you reference the appropriate type provider. So in this case, I'm going to access some crime data. We have crime data from 2006 to 2008 in the United States. That's this reference here. we create a connection to that service, which is done by creating an instance of the data gov crimes container from the service. And now once we have that, we can start looking at the tables of data coming from the data market. And we can start doing the sort of things we were doing before. We can start to look at do queries over the data for areas where the population's not zero, etc. Violent crime is above a certain level, and start to chart those results. Or we might do a query where we're now looking at the ones in California. Okay. So let's pop these windows away. So just to mention that the underlying technology that the data market is using for most of the data sets is OData. But one of the things I like about F# type providers is it means you don't, as a consumer of these information spaces, you don't need to be quite so aware of the underlying mechanisms that are being used to access the data. So what we've seen there is we saw language-integrated web data, language-integrated ontologies. Now we're seeing language-integrated data markets. But what we've done in F# 3.0 is, in the box, is not put, those two examples that we see are actually just samples of type providers. They're not shipping with F# 3.0 in Visual Studio 11. What we're focusing on is the enterprise data sources, or the data protocols, SQL, OData, SQL. There's a reason why SQL is there twice, and WSDL. And what I want to go through here is to get across that the type providers not only allow you to connect to these different data sources, but they make these different data sources extremely regular and simple to use. So the reason why SQL is there twice is because with F# 3.0 you can do either link to SQL or link to entities. So with SQL data connection, all you do is give the connection string, which will normally be a bit longer than the one here, but the dot's there, as an argument to the type provider reference. And one of the things here is these type providers can take static arguments, giving things like connection strings or a configuration file where the connection string is stored, which is the equivalent of the data that you would put into add service reference in Visual Studio. So this uses, SQL data connection uses link to SQL, presents the object relational mapping using link to SQL ultimately. This generate tag is only needed in the developer preview. That will go in future releases, so I'm just going to drop it from now on. Now, once you have that connection, then the types in your database are now available for use. That's all you need to do. It's a very code-focused way of accessing SQL data. You then call SQL getDataContext to actually establish a data context for working in. And then after that point, you can start doing link queries, which is the F# syntax for link queries is very close to the syntax in C#. And for item in the customers, you select item.name, and you have your data in your hands, just using iQueryable, just like you would expect from C#. The reason why SQL was there twice is because we also support Entity Framework. So instead of using SQL data connection, you can use SQL entity connection. Again, you just give a connection string, and everything else will be the same. Now, the presentation of the type space may change very in a minor way, but otherwise, you can just go ahead and start using your tables and start working with the database pretty much directly. Similarly, when we use OData, again, you just give your URL, which is the URL for the OData service, and that creates the types for the OData service, and you can get a data context, very similar you'll see, and then for each of the titles, for instance in Netflix, you can select the name of the title in a link query. And finally, just to say you can do WSDL services as well. There are very good directories of WSDL services available. If you look at things like programmableweb.com and other directories of WSDL services, there are hundreds and hundreds of these that are available. Again, you just give the URL. In the developer preview, it only works for HTTP-based WSDL services, a couple of restrictions which we've been gradually lifting. So here we get the HTTP service client for that WSDL service. And this is a currency conversion service, which allows us, once we have the client, to give two currency codes, such as the Chinese renminbi and the US dollar, and can get the conversion rate between those two currencies. So simple code for data access. It allows you a form of data access which has low tooling and you can use in a script-oriented kind of mode. That's one of the main reasons, one of the background reasons to why we're taking this kind of approach to F#, very code-focused approach rather than just duplicating add service reference and the like, is it clearly works very well in a scripting environment. It's harder to imagine what add service reference would look like in a scripting environment. It would have to look something like this, but you wouldn't want it to be using code generation and adding files to your projects and things like that. That sort of wouldn't work in a scripting context. Okay, so let's take a look at some of those examples. So let's take a look at, first of all, using Netflix here. Again, we have a couple of references at the top of our script, and we to get going with the built-in type providers for F#, you reference f#.data.typeproviders.dll, which just contains these built-in type providers for OData, SQL, and WSDL. If we want to see what different type providers are there, you can see there are OData, WSDL, SQL data, SQL entity, and also if you have DBML files or EDMX files, there are other ways of accessing SQL. Okay. So once we have that, we can now construct our service reference, which is as simple as, let's go through and actually type this in. So you get IntelliSense completion there. When you press the angle brackets here, it'll tell you the different parameters, static parameters you can give as part of your type provider reference. You can give a service URI. If you want, now when you give a service URI, it will be directly connected to the service. So it will actually only work if you're connected to the internet. If you want it to store a local schema file to allow you to work offline, you can optionally give the local schema file as an argument. And you can optionally give a force update, which means always try and update that local schema file whenever I use the service. And there's type providers usually come with anywhere from a couple to 10 different optional static parameters that you can give. So here we're just giving the service URI here, which I'll copy here. You can name that reference if you like, service URI equals, and then you paste that in. And then as the type checking kicks in, that will go and connect to the service. Excuse me. Yes, it's going to tell me that I need to have the generate tag. Okay. That's in the developer preview. So now we have that. We have our types, and we can go and see what is available from that particular service. So we've made it nice and simple. There's only one thing you usually want to do to a service, and that is to get a data context for the service. There's also a set of service types which are associated with the service, which you can use directly if you wish, which correspond to the types you would have got from add service reference. So we'll do a get data context, this, and we'd better evaluate these lines here. Okay, so now we're connected to Netflix. And then the next thing we've done is to really simplify the data that's available. You'll notice it just shows you the data that is available in the titles, the title awards, the people, the languages, and the genres of the different titles, of the different information about the movies stored on Netflix. So now we have the titles. We can show those on the right. Okay. And we're working with the data coming from Netflix in a very similar way we were working with the data from the other kind of services. Okay. So as our final look at these enterprise data services, I'm just going to show you a small ASP.NET application which demonstrates this principle that you can use the F# as a data access layer and then use it in a presentational layer in C# or Visual Basic. So if we go and take a look at our Solution Explorer, I've created a little application called Monster Movie House here. We have it's an ASP.NET totally bog standard C# ASP.NET project. And I've added an F# project as my data and analysis layer here. And if we take a look at the C# code here, then it's trying to access the data layer, which is not yet, which I haven't yet filled in the code for, and to conduct a Netflix search to populate a results list when the text is changed in the search text on the ASP.NET application. So here's the data access layer, and it's going to be made up of two halves. First is we actually specify the data access here. We create have an F# module containing things about the data source. We open the type providers. We make the connection to the Netflix catalog, and we create an instance of the Netflix data context. And then we have a second half here, which is a set of analysis and queries, which is in this case simply going to be a search of the data space, though you may put a lot of analysis code at this point of your F# programming. And this is going to search the Netflix catalog for the titles which contain a particular string. Okay, so this might be text to search for here. Okay, so now we've done that, let's build our application here. Okay, can we see now that red squiggly has gone and the C# project is now finding the F# project, and we can call in and perform the Netflix search, which will return the catalog items. And we can run our ASP.NET app. And we have welcome to the Monster Mystery Movie House, and we can type in the search box for some movie titles here. And we can see that the list, which is being populated through that F# data access layer, is coming back and being presented in the ASP.NET app. Okay. Of course, I come from a different generation where Attack of the Killer Tomatoes was a favorite title, so I always search for that. But unfortunately, it doesn't seem like I can get Attack of the Killer Tomatoes from Netflix, but I can get Return of the Killer Tomatoes, so I'll be getting that. Okay. Okay, so a couple of details about F# 3.0. First, I said we've added link queries to F# 3.0. Here's the syntax. You've seen it quite a bit already. It's slightly different to the C# one in that operations like take are included in the query syntax rather than as extension methods on the outside. So you don't do .distinct and .take. You put the declarations into the query syntax like you see here. There's a couple of differences. We use sort by instead of order by. That just fits with the F# naming terminology. And just notice that you do have to put this do at the end of the line here whenever you iterate or select from. The first line is equivalent of from in the C# link syntax. The next thing I want to look at is what does it look like to write a type provider. So this is a very, very basic type provider. A caveat here that it uses some support code, which is not yet released. We'll be releasing that as part of sample type providers. We're not going to be releasing it as an independent SDK, but we'll sort of be copying the support code into each of the examples. And what this type provider does is provides one type with one property, a static property. We have is static equals true, and inside one namespace. Actually, this namespace name should actually be this string here. Let's fix that. Okay, so when we use this type provider, when we go samples.typespace.name, it will return us the string hello. And you could easily expand this up to generate 100 types, and with 100, each of which have 100 properties. And then the set of types that you produce, you could then extend the type provider so that it depends on some backing data store or some backing data service. But as you can see, it's relatively straightforward to write type providers. The one part that maybe looks a bit funny is this part here. And this is effectively a link expression or an F-sharp quotation that tells the F-sharp compiler what code to use when this type, this provided type, is actually used. So the F-sharp compiler will be looking at all these provided types and provided properties, and it will see, oh, there's a use of this property called name. I'd better go ask the type provider how that property is actually implemented at runtime. And here this code is saying, well, it's implemented by replacing that property with the text, with the string hello. A few more details about F-sharp 3.0. We've been working a lot on the IntelliSense implementation. That's very much because type providers are clearly sort of associated with the quality of the way that you're using the metadata. The better tooling, the better IntelliSense, the better red squigglies and so on you can give, then the better the experience of using these data and information spaces, as well as improving F-sharp programming more generally. We've added auto properties, just like in C# and Visual Basic. Parameter help when using methods. There's many more samples and much better documentation. We have better nullable support. We've paid attention to some details, like F-sharp type providers can be used with F-sharp units of measure. And that means if you have a data store which has unit information to say that these numbers are actually meters or kilograms or represent, so whether they're meters or feet or inches or which unit system it's in, that information can be propagated across into F-sharp. As part of that, we put the standard SI units of measure into the F-sharp core library. And F-sharp also benefits from many of the improvements made in the .NET 4.5 and in Visual Studio itself. So to summarize, the way we look at it is that F-sharp 2.0 is an accelerator for solving computationally complex problems, the problems that were in the center box of my original slide. And that F-sharp 3.0 extends that to allow F-sharp to be an accelerator for solving data-rich or data-complex kinds of problems. So next steps for everyone here, I'd ask you to consider using F-sharp 2.0 for the center part of your work. I'd ask you to consider using F-sharp 3.0 for these two parts of your work. And I hope you all also very much enjoy using all the new offerings from C# Visual Basic, all the async programming for the presentational work from C# and VB, for all the associated parts of your programming. So F-sharp 3.0 is ready for use, will be ready for use in VS11. F-sharp 2.0 is ready for use in Visual Studio 2010. And it's really about code-focused analytical programming. And I hope I've convinced you that we have an amazing data-rich future ahead for the language. So some more information. And I'd like to thank everyone for coming along. And we have about 5 minutes for questions as well. Thanks.
One question. You showed a type provider for OData. OData is not only for consuming data, but is also able to write data.
Yes,
Can
that's
you
right.
speak about writing with type providers?
It's just supported as it is. Most of the samples we show are always about consuming data because they give good demos, but all the methods here. Hang on, this might be a read-only service. Let me work. What's it? Netflix might be read-only. Let me. take a look at one of the SQL examples. So yeah, to take a look at the SQL example, we have a connection string here just to the usual Northwind database, which is specified by this connection string accessing this database here. And once we have the data context, we can go to the tables on the database, so the customers table. And if we wanted to add to the database, we would simply just go insert on submit. And so writing data is just a set of methods to write back to the database. There's no, you just call a method and you write back to the data service. There's nothing intrinsic that type providers are about reading data. It's really about projecting information space and projecting a set of methods you can use to manipulate that information space as well. Does that answer your question? Please make sure you use the microphones for the question.
So is it the case that the types I generate out of a custom type provider can have methods on them that can be invoked as well?
Yes, so we're seeing a set of methods here on a set of provided types.
And did you say that I can use F# 3.0 in VS 10 and target .NET 4.0? Is that correct?
No, you use it in F# 3.0 is in VS 11.
Only in 11?
Well, we will be continuing to ship the standalone tools for F#, which you would use, and you'll be able to run your F# code on 4.0, but F# 3.0 is really in VS, with the Visual Studio tooling support, will be in VS 11.
And is all the information available now to write a custom type provider?
Not all. No, we've put out all the information about type providers and the API is there, but we haven't yet put out the samples to write a custom type provider. We'll be addressing that over the coming weeks.
Thanks.
Yeah. I should add on that note, we would absolutely love your feedback, especially in the next month or so, because that would allow us to action your feedback as well as we can as we continue on with VS 11. So over this side.
You made a comment before that you could use portable component DLLs to interrupt this with the Metro stack.
That's our plan of record. That's our roadmap, yeah. Okay,
I'm not sure what that actually means. Does that
mean in the developer preview, as you have it today, you can't do that? It's possible you could get F# code to run on Metro with a fair bit of work, but you can't do that with the bits you have in the developer preview today.
So is the WinRT type system available to F#?
That's not available in what you have today. That is what we're looking at with the portable work and the other, and going ahead.
Because a type provider working with contracts like a search contract or working with a sharing contract would be very powerful.
Yeah. It opens up a lot of possibilities in all the kinds of programming that you can do. Metro programming is one very important growing area of programming, but there's been a bit of a tradition on the F# team that we often focus on enterprise programming for just because of F# use in financial companies and other places. So that's been our primary focus on this release.
Thank you.
Over this side.
Do you know if there's any plan to support OWL and semantic web ontologies?
So in terms of a plan, the F# team itself don't have a plan. We really expect there to be third-party type providers, whether they're provided by the F# team. We'll be providing samples and added sort of bonus packs. It's one of the reasons why we did F# type providers was to allow us to add a lot of extra value to the F# programming experience, sort of out of band, without necessarily being part of the core Visual Studio release. I do expect the F# community to have interesting projects. If you're interested in that kind of question, in particular these open standards such as Sparkle and Semantic Web, then I'd encourage you to get involved with the F# community in some sort of shared project and look for the F# open source community or the other communities like the F# user groups and the like for action there. And I think one last question here.
I'm not an experienced F# programmer, so I hope my question is not silly. As far as I understand it, this type providers read the schema at runtime. If
No.
I consume
No, they read the schema at compile time.
at compile time.
Yeah,
Okay.
that's it. That's right.
So when I consume this stuff in C#, I don't get DLR objects. I just get plain old CLR object with strong typing.
It depends. There's two kinds of type providers, ones which give you real .NET types and ones which erase the .NET types. And if you use the ones that give you real .NET types, then from the C# programmer's perspective, you get real types with strong IntelliSense and everything, but not if you use the erasure. And thanks everyone for coming, and it's been a pleasure to be here at Build.